Hello everyone, I welcome you all to my YouTube channel. So today I'm starting with class 10 mathematics, second chapter polynomials. So the books that I'm going to cover for this chapter is NCERT, the most important for board perspective, NCERT Exemplar, RD Sharma, RS Agarwal, and 10-year board papers. So I think this is enough for board preparation and you can solve any questions if you solve these five books. Most of the people are scared from RD Sharma. I don't know why. I find it very easy. So I've covered most of the content from there only. You can refer that book. So in my first video, I will be covering the theory of polynomials briefly, telling you all the formulas and covering just the basics. Only the theory which will be required in my next video, which will be covering the questions. And I'll cover all the questions which are relevant for board from all the books so that you need not search the books. And one feedback I would request you all to give me that whether I should make a video in English or Hindi or mix both English and Hindi because I don't know in which language all of you will be comfortable. So today I'll be mixing both of them so that everyone is comfortable. So let's start it in the video. So what is a polynomial? You must have seen expressions like this in your maths. These are numbers 2, 7. This is 9x plus 7, 2x squared plus 3x plus 7. This is 14x cubed plus 9x squared plus 7. So these are quite common, right? So the symbol x here, x is a variable. X is called variable here. And these numbers, like in this 2x squared plus 3x plus 7, these 2, 3, and 7 are called coefficients. Note, coefficients may be positive, negative, or 0. Here, coefficients are positive, plus 2, plus 3, plus 7. It may be the case coefficients may be negative. Even they can be fractions also. So basically, they are integers, fractions, anything. Okay. So now I come to the general definition of polynomials. Polynomials are represented as fx equal to, this is the representation, x to the power n into an plus x to the power n minus 1 into an minus 1. Similarly, continuing till x square into a2, x1 into a1 plus a0, where a1, a2, an are real constants, means they are real numbers, and n should be positive integer, this n. So, confused, right? हम मुझे भी पहली बारी कुछ नहीं समझ आई थी ये डेफिनेशन. सो मैं समझाता हूँ ये होती क्या है. डरो मत. हम रिलेट करते हैं इसको जो पहले एग्जांपल दिया था मैंने. सो आई गेव द एग्जांपल 3x minus 2 earlier. So what is n here? N is 1, the highest power degree. I'll teach what degree is also. By intuition you will be guessing n is 1 here because the highest power of x is 1 here. So I'll start from left. This is a0, a1x, with no other term, so we'll stop here. So the a0 is minus 2 and a1 is 3, represented in this form, a0 plus a1x. Now in the second example, I'll start from left. a0, a1x, a2x square plus a3x cube. So this satisfies my definition of polynomials, right? So a0 is minus 1, a1 is 3, a2 is minus 3, sorry I have written it minus 2, and a3 is half. Now I have written this polynomial in variable z and not x. Doesn't make a difference. Just this is now a polynomial in variable z instead of polynomial in variable x. But this is also a polynomial. So the degree n which I mentioned should be positive. What I mean is that, like in this case, degree of means not degree, like every term power, variable power. Here a power of x is half, but that is not acceptable. It should be a positive integer or 0. So this is not a polynomial. Next example is this. In this, there's no degree defined. So this is not a polynomial. Third example is this one. So in this case, power of x is minus 1 because 1 by x can be written as x to the power minus 1. So power of x is minus 1. So this is again not a polynomial. So now comes the degree of polynomial. What I mean by degree of polynomial. The exponent of the highest term in the polynomial is known as its degree. In this case, y square is the highest term, so 2 is the degree of this polynomial. What is in this case? 3 is the degree. Yes, you have guessed it right because 3 is the highest term. So based on the degree, we classify the polynomials in this way. First is the constant polynomial whose degree is 0. This includes numbers like 2, 7 and any constant number. Now, important note to here is that constant polynomial 0 is also called is the constant polynomial 0 is called 0 polynomial. Note 0 is also a constant polynomial, but it is given a special name 0 polynomial. Why? I'll let you know. What is the degree of 0 polynomial? Degree of 0 polynomial is undefined. Why? Because you see these three cases: 0 into x, 0 into x square, 0 into x to the power 12. All this will give you 0. So degree is not defined because x to the power 1 can also, so 1 can also be degree. It can be written as this also. So here 2 is also degree. In this case 12 is degree. So there's no unique degree. So degree of 0 polynomial is not defined. Then comes linear polynomial. Already discussed, degree is 1. Example 2x plus 3, x highest power of x is 1. Quadratic polynomial, degree is 2. Now see here, the coefficients are fractions, so don't worry. They can be fractions also. The highest power of x square x is 2, so degree is 2. Cubic polynomial, 6x cubed plus 9x plus 1, degree is 3. Note the lower power terms like x square is missing here, so they can be missing. So what is the coefficient of x square here? Coefficient of x square is 0 because 0 into x square will be 0. So I told you coefficients can be 0 also, no? So next come is biquadratic polynomial, degree 4. I have written the general expression of biquadratic polynomial. These are just named, not so useful. Just for the sake of theory and completeness, I'm covering. In next video, I'll be covering all the important questions. Value of a polynomial. Fx, value of fx at x equal to 2, how we represent it? F of 2. Similarly, for at any general point x equal to a, the value of fx is defined as f of a. Now comes 0 of polynomial. X equal to 2 is a root of polynomial, fx equal to x minus 2 because f of 2 is 2 minus 2, 0. So f of 2 is 0. So x equal to 2 is root of this polynomial. Similarly, generalizing this concept, x equal to a is a root of polynomial f of f is a root of polynomial fx if f of a is equal to 0. F of a is what? The value of polynomial at x equal to a. So it is 0. F of a is 0. If it comes, then x equal to a is the 0 of polynomial fx. Now comes the graphs. So you can see the complete details in R.D. Sharma book. There are a lot of solved questions for basics. I've just covered the overview. So if you are not much familiar, then cover from there. I'll explain you briefly. So this is the graph of constant polynomial. Here y is equal to some constant, suppose 3. This is a constant polynomial. Another constant polynomial could be x equal to 3, suppose. That would be a vertical line parallel to y-axis. This is a graph for linear polynomial. You must be knowing y is equal to mx plus c. This is graph for quadratic polynomials. This is an upward parabola. This is a downward parabola because it is opening up, so it's upward. Opening down, so downward. And don't be scared with this word parabola. This is called parabola, this shape. This is graph of a cubic polynomial, and this is a generalized graph. At most, three roots can be there for a cubic polynomial, and minimum one root will be there for a cubic polynomial. The graph of cubic polynomial in general looks like this. So linear polynomial will be covered in your linear equations chapter 3 in your book. I'll cover it in detail there if you want me to cover that. It's quite an easy chapter. Here I will cover in detail the quadratic polynomial and later some part of cubic polynomial. Your book also covers quadratic polynomial. An advantage for you covering will be that I'll cover quadratic polynomial, so your quadratic equations will also be completed here only. Just one or two topics will be left, and you must be knowing that quadratic formula. That is one part of quadratic equations. So there they give its derivation. So most of the part come from here only. So this is general representation of quadratic polynomial. It is called ax square plus bx plus c. Note a is not equal to 0, because if a is 0, then this term will be 0. Then the polynomial will become bx plus c, so its degree will become 1. But that should not be the case because it is a quadratic polynomial. So degree of this polynomial should be 2, so a should be non-zero. Now there are three cases. Because a is not 0, so we are left with 2. Either a is greater than 0 or a is less than 0. So I've drawn the graphs. Further three cases arise under each category. If a is greater than 0, then it will point upward. The polynomial will not point, will be it's facing upwards. In this case, there is no root of this polynomial. Similarly, in this case, there is no root of this graph, right? So here it is one root, or you can call two exactly equal roots, upward, downward, for a less than 0, for a greater than 0. Similarly, here there are two roots, a greater than 0, a less than 0. So a will tell whether it's an upward parabola or downward parabola. I already covered. These three graphs are for a greater than 0, these three graphs are for a less than 0. So what are the coordinates of this minimum? This, like this shape, the minimum point here, right? In general, its coordinates are minus b by 2a minus d by 4a. D is greater than 0 if two roots are possible for their polynomial, right? In this case, d will be greater than 0. Here d will be equal to 0, equal roots, and d will be less than 0, no real roots, right? So d greater than 0, two roots, d equal to 0, one roots, or two equal roots, d less than 0, no real roots. No real roots, right? But in class 11, you'll get to know that complex roots exist. So this all goes like, you understand what I mean. So value of d is b square minus 4ac. Now a very famous question based on this type is, you will be given a graph, and you will be given its equation, so you will find its coordinate, because you will be given ax square plus bx plus c. So its equation will be minus b by 2a minus, you'll get the coordinates from where, minus b by 2a minus d by 4a. Now since it's on the left side of y-axis, so x coordinate will be less than 0 and y coordinate will be greater than 0, because this point is above y-axis, x-axis, sorry. So given any graph, we can predict the signs of ABC. Since it's a downward parabola, as I told you in the previous slide, so a is less than 0 and minus b by 2a, x coordinate is less than 0. So now see here, I've multiplied with minus both sides, so b by 2a will be greater than 0. Why? If minus 5 is less than 0, then 5 will be greater than 0. Relate with this example. Now a is less than 0, so b will also be less than 0, so that division of these two will be greater than 0. You take an example. Suppose take b as minus 4 and a as minus 2. So denominator becomes minus 4 and numerator becomes -4 also. So the product becomes 1 greater than 0. Similarly, y coordinate is greater than 0, minus d by 4 is greater than 0. So d by 4 is less than 0, d is greater than 0 because a is less than 0 on similar logic, which I mentioned for the x coordinate. Take any example. So this is the point where the graph cuts y-axis because and its coordinate will be 0, c. How? On y-axis, value of x is 0. All of you might be knowing. Fx equal to ax squared plus bx plus c is the equation. Put x equal to 0. You get f of x equal to c or y is equal to c. So y coordinate becomes c. X will be 0. You understand, no? So only c will be left. And c is less than 0 because it's below x-axis. So we predicted the signs of a, b, c, right? And the discriminants also. So now comes the interesting part, alpha, beta. So uh, people generally get scared with this after seeing this. So these are Greek letters you will be using in maths, so be familiar with these. This is called alpha, this is called beta, this is called theta, this is called gamma, this is called delta, this is called phi. This is like ABC in our English language. They have some alphabets, just learn their names, they will be very useful. uh, they are just variables like x y z only. So quadratic equation ax squared plus bx plus c, it has two roots at max, alpha and beta, as we saw, and minimum zero roots. So sum of roots is alpha plus beta and it is given by minus b upon a. Suppose b is 2 and a is 1, so sum of roots will be minus 2. Product of roots alpha into beta, it's given by c by a, right? Now a is not 0, I already told you, so we can divide by a non-zero number, divide it, we get x square plus b by ax plus c by a equal to 0. Now substitute the value of b by a from here, b by a will be minus alpha plus beta and c by a will be alpha into beta. So if substituting these values, you get x square equal to minus alpha plus beta x, बी बाई ए की वैल्यू हमने यहाँ सब्सटीट्यूट कर दी, माइनस अल्फा प्लस बीटा आ गया, और सी बाई ए की वैल्यू हमने सब्सटीट्यूट कर दी तो अल्फा बीटा आ गया. तो इसको हम कैसे जनरली रिप्रेजेंट कर सकते हैं, एक्स स्क्वायर माइनस सम ऑफ रूट्स इंटू एक्स प्लस प्रोडक्ट ऑफ रूट्स. तो अगर हमें कोई भी दो मतलब पॉलिनोमियल की रूट्स दिए हैं, अगर हमें वो पॉलिनोमियल प्रिडिक्ट करना है, हम कैसे करेंगे, उन दोनों रूट्स का सम निकाल लेंगे, एक्स स्क्वायर माइनस सम ऑफ रूट्स इंटू एक्स कर देंगे. सम ऑफ रूट्स यहाँ पे सपोज रूट्स है अल्फा इक्वल टू 1 और बीटा इक्वल टू 2, तो एक्स स्क्वायर माइनस 1 प्लस 2 मतलब 3, एक्स स्क्वायर माइनस 3x प्लस 1 इंटू 2 इंटू प्लस 2, तो एक्स स्क्वायर माइनस 3x प्लस 2 आ गया हमारा पॉलिनोमियल, right? So ax square plus bx plus c can be factorized as a into x minus alpha into x minus beta. This is important. This is an example for the same. X square plus 3x plus 2 can be written as, this is a, I've written 1, and its roots are minus 1 and minus 2. So x minus alpha, x minus beta, where alpha is minus 1 and beta is minus 2, right? Uh, watch the video again if you are not able to get or I'm too fast, because it's just the basics, so I'm covering a little fast. I hope you guys must be knowing this, right? So next is cubic polynomial. General representation is this. We have seen it many times. I have told you there are at max 3 roots of a cubic polynomial and minimum is 1 root. So I've written these roots as alpha, beta and gamma. Sum of roots is minus b by a, alpha plus beta plus gamma. Now this is called product, sum of product of roots taken two at a time. मतलब sum कर रहे हैं किसका, प्रोडक्ट ऑफ रूट्स का, और प्रोडक्ट ऑफ रूट्स ले रहे हैं टू एट अ टाइम, और दिस इज कॉल्ड थ्री एट अ टाइम. दिस इज वन एट अ टाइम, टू एट अ टाइम, थ्री एट अ टाइम. और यहाँ लेफ्ट से चलना शुरू हो जाओ, यू गेट माइनस बी बाई ए, फिर माइनस प्लस माइनस ऑल्टरनेट चलना है, माइनस बी बाई ए, सी बाई ए, माइनस डी बाई ए, और असाइन करते रहो. फर्स्ट में टू एट अ टाइम, सॉरी वन एट अ टाइम, देन टू एट अ टाइम, देन थ्री एट अ टाइम. If you don't understand what I'm trying to say is, then see these three formulas. Sum of roots taken one at a time, 2 at a time, 3 at a time, minus b by a, c by a, minus d by a, alternate. So this is same summation of products taken one at a time, same thing which I was telling you. So this cubic polynomial can also be factorized as similarly on the basis of quadratic polynomial. How we factorize, we are factorizing cubic polynomial a into x minus alpha, x minus beta, x minus gamma, where alpha, beta, gamma are the roots of the cubic polynomial. Now the last part comes the division algorithm in this chapter. We are studying it from the basic classes, dividend equal to divisor into quotient plus remainder. Everyone might be doing this, but I'll cover some. This forms an important algorithm for solving questions in your board exam. So here comes the end of the complete theory of the chapter. I've covered the complete theory, complete basics. This might be quite basic video for some of you. I apologize for that, but this was necessary before I could cover questions. Now, from the next videos, I will cover all the important questions, and if you go through them and solve them, your chapter will be complete and you will be ready for the exam, because I'll cover your board exam, board questions also, and all from all the books that I mentioned, right? So if you want to post any doubt or any topic that I missed, you can post in the comment section. I'll answer your doubts. And thank you for today. That's all. Goodbye.